Makes me wonder why we bother having lectures at all. Must have hit the wall at some point, has everybody. Alright, so what's new? Oh yeah, people have been asking about assignment marking. We'll try and get it done ASAP. Assignment 2 might be a little bit provisional on how efficient your queries are. If someone writes queries that take 3 seconds to run, there are 10 queries, 30 seconds, 500 students, and we've got to run it twice, so it's a minute per student, 500 minutes, okay, that's not too bad. Funny, I'm sure I sat down the other day with Hayden and worked out that if everyone wrote really slow queries, it would take 3 weeks to run the auto marking. Well, who knows? Alright, so the assignment's out. Someone just told me they couldn't load the database. Is anyone else in the same trouble?
The name's wrong.
Huh?
The packet, the CS131 is like this, AS3.
Yeah, okay. That's fine. You can always change that. Grab a copy. But actually loading the database from the dump file, no problems apart from one person. Alright, I'll better check with that. Oh, has anyone actually tried to load it? I can't see, and it worked. Yeah, strange. I can't see why there'd be a problem loading from a dump file, but anyway, because it must have worked in the first place. Another nerd. This time, however, not a DB nerd, but someone who's slightly relevant. Who is it? Correct. You're just guessing that from the context. Right, Guido van Rossum. So he invented Python. He did computer science at the University of Amsterdam and maths, and created Python around 1989. People thought that was a really cool thing to do, so they made him benevolent dictator for life of the Python ecosystem. A position that he held until 2018 when he said, no, this is all getting too big, so I'm backing out. So he worked at various companies right up till this year, when he decided that'll do, probably made enough money, time to retire. So he has. So very useful contribution though, inventing something like Python, which has kicked off. And he didn't do all the rest of the library developments and so on, but certainly setting up the ecosystem for that is a good idea. Alright, so I think we got to about this point last time. So we want to connect programs to databases, and we need some kind of API for that. So the typical API, and this isn't a real one, this is just something that gives the general flavour, make a connection to the database, get some kind of handle that allows you to do things on the database, construct queries. Generally what we're doing with queries is we've got some kind of SQL statement, but we want to push values into it to ask the query, so that it won't actually be a statement, it'll typically be, it won't be a complete statement, it'll typically be some kind of template into which we push some values. That'll give us a query. We then execute that query on the database. Basically that means sending the SQL string down the pipeline into the database engine, which runs, produces some results. We get back a handle on those results. We don't necessarily get back all of the results all at once, and then we'll have some kind of way of iterating through the results, fetching one result at a time, where a result of course is a tuple, so we iterate through all the tuples in the results there, and then within the program we can do something with whatever's contained in each tuple. So that's the general structure, and plenty of APIs look kind of like that, even Python, which is the one we're going to look at and use. So, as I just said, a lot of these kind of libraries have a similar structure, but they're all different. They've all been designed by different people, and they all have different function names, slightly different ways the functions work. Some of these libraries, like PsychoPG2, are specific to a particular database. So that one only works with Postgres, although it is based on a generic API that Python uses for accessing lots of other databases like SQLite, for example. But there are, something like JDBC is a completely generic API for databases. It's meant to work with every database. Basically what you do when you set up the connection, you say what kind of database you're connecting to, and then everything else flows from that. Some interfaces are more O flavoured than the API I showed you on the previous slide. Obviously they all differ in what the functions are called and what parameters they take. How do you extract or how do you push values into the SQL statements that you're sending to the database engine? And once you get back a result, it's going to look like some kind of data structure in your program, and then how do you extract the components? So some APIs you actually have to explicitly say, here I've got a tuple that I got back from fetch next tuple. Then if I want to get, maybe it's got a field called X, then I say fetch from this tuple the field X, and it's actually a function that does that. Other languages like Python and PHP give you back a data structure, and it's very easy just to pull the components out of that data structure. Sometimes you can treat it like an array and just grab the ith element from the array. Now there are a bunch of APIs, I guess you could call them, that are very heavily object oriented in flavour, and basically what they try to do, they try to give you a view of the data as a collection of objects, and they try essentially to hide from you the underlying SQL representation of those objects. Some of the ORMs you specify what these objects look like in an OO type notation, and then you say something like create database for these kinds of objects. It goes away, generates the SQL for you, and then you assign values to an object. Those values get pushed to a table in the database. So at some level, you don't have to deal with SQL at all. Generally, when you're asking queries from these databases through an object relational mapper, they all have a tendency to invent a way of specifying things that are very easy to specify in SQL. So how you filter with the where clause, there'll be some kind of filter operation that you can apply to your objects. That's all very nice if you want to program in an OO style and never worry about the database SQL structures at all. However, these kind of wrappers have a tendency to, when you specify that you want to access a particular collection of objects which are stored perhaps in multiple tables, or the values for each object are stored in multiple tables, they have a tendency not to produce efficient operations to access the database. And that's the reason I said right at the start that I didn't like object relational mappers. So fine if you want to be an OO programmer and you never want to learn anything about SQL. That's good for you. But you're going to have to put up with, fine, it's easy. I can define my entire problem in terms of objects, and I never have to deal with the database directly, but I'm going to have to put up with potentially inefficient access to the database. So even though, and PsychoPG certainly doesn't fall into that category, you have pretty direct access. You know what the tables look like. You're directly asking SQL queries, so you've got the chance of doing things efficiently. Trouble is, you've also got the opportunity to do things extremely inefficiently. And I wanted to have a look at some examples here. So database systems are set up to deal with sets of tuples, and they deal with sets of tuples extremely efficiently. There's a whole lot of technology sitting in the background to do filtering operations and join operations and so on. So they can very efficiently produce a large set of tuples. On the other hand, programming languages tend not to deal with sets of things, they tend to deal with individual things. So somehow, database goes ahead and produces lots of tuples. In the programming language, we probably want to deal with those tuples one at a time. That leaves the fact that you can write multiple queries from your programming language to access the database, and in particular, the fact that you can write nested loops, where you've got an outer loop which runs one query, and inside the loop you've got another query that you've got another query being executed each time through the loop. That's a particularly bad way to do things, and I'll show you some examples of that pretty soon. So basically, this all crops up because various operations cost a lot. So establishing a database connection is probably the most costly operation in a database programming language API. Fortunately, you only tend to do that once at the start of your program. So you make the connection, then you ask queries on it. Each time you ask a query, that's relatively expensive, not as expensive as establishing the database connection, and accessing individual tuples is relatively cheap compared to these two operations, but still possibly slightly expensive, and we'll explore how expensive it is later on. Right, so here's an imaginary database API, really just to illustrate some points about how you can use the API badly. You can do exactly things that are analogous to this in the Python API as well. So we get access to our database, we ask a query on the database, and we fetch tuples from the database one at a time. And here we assume that when we get a tuple, we can extract the individual components by giving the name of the attribute as an index into the tuple object. Alright, so that's pretty straightforward. So DB access operation, relatively expensive. DB query operation, transmitting the SQL statement to the database and waiting for it to produce some results is relatively expensive, and the function to fetch each individual tuple is relatively cheap. These I just made up, these numbers, maybe I've got it totally wrong, and maybe DB access is 1,000 milliseconds or something. When we're talking about how we use the database and how much it costs, I'm basically going to ignore DB access because, alright, that's there, you do it once at the start. And it's really the things you can do after you've got access to the database that can cost. So here's an example. We want to get a bunch of mature age students and we want to do things. Maybe we just want to count them or something. Of course, you can see that there'd be an easy way to do that in SQL, but there's a little bit of a tendency to do things like this. So, all right, I need to find mature age students. I'll get all the students. So select star from students, run that query, fetch all the tuples, and check each tuple to make sure that I'm dealing with a mature age student. If I'm not, then I can just ignore and go and get the next student. All right, if I've got 10,000 students and not many of them are mature age, then we've basically transferred 10,000 tuples. We've got to fetch all the students, and we only end up dealing with 500 of them. So it's going to end up, according to my cost parameters, it's going to end up taking that long, which of course would fail you in assignment 2, auto testing. Now, of course, we know how to filter stuff in databases, so rather than saying select all students and then filtering in the program, we would obviously say select from the students where their age is greater than 40. So this is how you should do it. So it's only going to require you to fetch the 500 tuples that are actually relevant to the problem, and then the cost will drop from 100 seconds to 5 seconds, so you're going 20 times as fast. So that's one way you can mess up your use of the database, and I've definitely seen people do that before. Another way is, let's say we've got an example we want to get for each student, we want to get a list of their marks. So as soon as you say the word for each student, we do a select to get information about each student. And we read the data about a student, but then, given that data, we need to go and get information about their marks. So for each student, run this query here. That'll give us all their marks info, and we can do stuff with that, maybe calculate a WAM or something. So we've got an outer loop which is fetching 10,000 student tuples, and we've got an inner loop which is fetching some number of tuples for each student. Now, of course, that depends how many subjects they've done, i.e. how many marks they're going to get. But let's say, for the sake of argument, that the average number of marks per student is 8. So we're going to run this query once to get all the students, and we're going to run this query once for each student. So we're going to execute that query 10,000 times. So we're going to end up with a cost something like this, which is pretty expensive. How do we solve this problem? Well, we don't have an outer query that does something, and then for each tuple in the outer query, do another query to fetch information relevant to the current tuple. Obviously, we use a join, which is what we normally do. So this requires us to ask one query, not 10,000 queries. We're still going to have to do some processing. One thing that I should have added to this query here is that we order by the student ID, for example. So what we're going to fetch from the query is a bunch of data for one particular student, then a bunch of tuples for another student, then a bunch of tuples for another student. And depending on what we want to do with that, we might be able to use a group by to try and summarise the data in those groups. But certainly if we order them by the student ID, we can recognise, all right, same student, same student, same student, student has changed. So at this stage I collected all the data about that first student, and I can do some calculation with it or do some summarisation with the data that I've collected. And then I start collecting data for the next student, and I keep doing that, same student, same student, same student. Eventually the student changes, so I deal with that student, and so on and so on. Right? So it's an iteration across all the students, but we're just reading the 10,000 students plus for each student we've got on average 8 tuples. So the cost is still quite expensive. I was surprised it came out so much, but it's a lot less than that. So never, ever, ever, and I don't want to see this in assignment 3, write nested queries where we've got the outer query, a loop over the results for the outer query. For each result, execute another query, or even worse, execute several queries to collect information relevant to that tuple. So don't do that. To some extent, correlated subqueries, which we dealt with a little bit in SQL, have a little bit of that flavour. So the outer select, where you say select from bars or whatever, and then where something, and do another query for that particular bar, has a little bit of that flavour. And those kind of queries, those correlated subqueries, tend to be slower than doing things with a join, if doing them with a join is possible. Alright, so we're going to use Python as the programming language. Everyone abused me for using PHP, so I decided, alright, everyone knows Python, so we may as well use that. Turns out that not everyone does know it so well, but you don't need to know much Python to interact with databases. So I'm assuming that you'll pick up enough as we go to get things done. If you desperately want some revision on Python, take a look at the online tutorials. So we're just going to sort of learn Python by example, if you like. So we're not really interested in Python per se, we're interested in accessing databases from a programming language. Alright, and what's the API? It's the one that I call PsychoPG2. I don't know how everyone else pronounces it, and I don't know how it's supposed to be pronounced, but I noticed Hayden the other day was calling it PsychoG2, which sounded a bit strange. Maybe we should have a competition to come up with a good way of pronouncing it. I'm sticking with PsychoPG2. Like the sound of that. Alright, so it's a Python module that gives you ways of connecting to a database, doing the authentication step that I talked about before, then a whole bunch of exceptions that might occur with the database, like I can't open the database, or I'm given the wrong name or something, or you ask a query that's invalid because you're specifying a field that's not in that particular table, and also a bunch of constructors for dealing with types and objects. So there's always going to be a little bit of a tension between the way things are stored and represented in the database and the way that they're represented in the programming language. Most of these APIs are pretty good at doing conversions. When you get a tuple in from the database, and say it's a text field or a char 10 field, it knows how to convert it to a string in a native string programming language. So things like that. Alright, so if you want to use PsychoPG in your program, you just simply stick import PsychoPG2 at the start. Of course, that's not going to work if the system that you're using doesn't have PsychoPG2 installed. Fortunately, Greek does, so if you log into Greek, you'll be able to use this module. We've got 2 versions of Python installed on the system, which is slightly annoying. I'd rather just have one. But Python 2, if you just type Python on the CSC systems, I think by default you get Python 2. If you want to run Python 3, you actually have to type Python 3. Alright, so how does PsychoPG fit into this scheme? This is basically the diagram I showed you last time, where over here I had generic programming language and generic database API. So we've still got all of these things that are the same, and we've still got the problem that these cost a lot relative to how much it costs for the Postgres server to access the data on the disk. So there's an authentication connection step. You can send SQL queries and you can fetch result tables, and that's pretty much all you need. Alright, so how do you set up a connection to the database? Well, PsychoPG2 object, if you like, or module, has a connect method. And to connect to a database, you need to specify certain information. Obviously, one thing you need to specify is what database you might try and connect to. So you have to specify a database name. Depending on how your Postgres has been set up, you may need to specify a user and password. On Greek, you don't, because you're effectively the Postgres super user for your server. So, and the way we configure the access controls, you as a user can do anything you like on your server. So you don't need to worry about those. If you've got Postgres installed at home, depending on how you installed it and how it's configured, you may need to have created a user, and that user might have a password, so you might need to specify these things. So this thing is just a single long string where it's got things like DB name equals the name of the database, user equals the name of the user, password equals blah blah blah, host equals whatever. So also in general, you might need to specify where the server is running, and you might need to specify which port the server is using. By default, Postgres uses 5432, but the way we're using it on Greek, we're not even dealing with ports and so on. We're using Unix domain sockets, and so we don't really need any of this stuff except for the database name, obviously. Right, so here's a very simple script that just connects to the database and then disconnects from the database. So import the module, and then, okay, in Python you can specify that you want to attempt to do something and then have exception handlers to deal with things that go wrong. That's a sort of fairly common structure amongst modern programming languages, not so much in languages like C. But in any case, so we can make a connection if we had a database called MyDB, and if we were able to access that database, then the call here, the call to this method, would produce an object which is a connection object, which then allows us to do other things. This script isn't doing anything interesting, it's really just opening the connection and then closing it again. So once you've got a connection open, you close it by doing that. If any of these things fail, we'll jump down to the exception handler, and generally the thing that's going to fail is this, because maybe you don't have a database called MyDB, and so then you'll end up printing that error message. Now the connection itself is an object whose internal structure is slightly opaque. So if you print it out, you get some information, but a lot of it maybe isn't that useful. But you can see the address of the connection object, you can see what the connection string was, so it's basically just a copy of that. And when we do the first prints, after we've initially made the connection, we see that the connection is not closed, which is handy because we just opened it. After we close the connection, if we then print information about that object again, that connection object, we now see that closed is true. So that's not doing anything useful, but it's just showing you how you access a database from Python program. If you look at that CS3311 .py thing, which Hayden has set up somewhere, you'll find that that basically tries to hide all this stuff. So it gives you a message that you can call that will give you back a database connection, assuming that the database works. So it handles the exception, so you don't have to worry about it. You just call it, and if it comes back and gives you a connection, it's giving you a valid connection. If there's something wrong with accessing the database, then it doesn't come back at all. Let's see. Have I lost? Oh, I've still got my connection. Beauty. Alright, so I think I've actually got this. Yeah, so that's what we're just looking at, minus the comments. No, it's not. It's not exactly what we're looking at. Alright, so in the previous example, I just had a string that said DB name equals, and then it actually had the database name hardwired there. It's also perfectly possible to get the database name from a string variable, and if you want to do that, you need to concatenate the that part of the connection string with the actual database name. And you can see how you could do that for if you actually had to have a username and password and so on. You could also define all of those at the top. And rather than saying unable to connect to the database, we actually say what the name of the database is that we can't connect to. So if I want to run this script, okay, so that's pretty much the same as what we saw on the slide. Opens the connection, tells me that it's not closed, tells me which database was involved, and that's pretty much it. Alright, so that's nice. I don't want to always connect to the same database, probably. So how can I set up a connection, or how can I set up a script so that it takes the database name from the command line? So for example, I've already got it here in, I think, Python. Alright, so it's giving me a usage message because I didn't provide a database name to connect to. So I know that database A2 exists, and that gives me essentially the same result as before. Different address, of course, but it doesn't matter. And I've also got another little database called MyDB, and I can connect to that. And if I pick some rubbish name that isn't a database, then it tells me that. Okay, so let's have a look at the script. So for this, we need to do some argv processing. So we simply check how long the argv list is, and if I don't have at least two things in the argv list, then it complains. It tells me that I ought to supply a database name. sysargv0 gives me the name of the script itself, pretty much like C, and then exit, pretty much like C once again. That will quit the program. Alright, if I want to get the name of the database as specified on the command line, then I can do that, get the first command line argument, and then once again stick it in the thing, make a connection, and close the connection and then finish. And of course, if I can't connect, then it will print the error message. Let's see. Okay, so that's a pretty straightforward extension of that with a little bit of argv processing. Feel free to ask questions if there's some aspect of Python that doesn't make sense. Alright, so once you've got a connection, what can you do with it? One thing you can do with it, probably the most important thing you can do with it, is not close it, but is to set up a cursor. And cursors are really critical in COMP3311. They're basically the mechanism that allows you to run queries and get results and so on. So you you create a cursor. Once you've got a valid connection object, you then use the cursor method on that object, and that will give you a cursor object. You can then use that cursor object to fire off a query. Once you've fired off the query, you use the same cursor object to fetch the results of the query. We'll say more about cursor objects in a minute, obviously. Another thing you can do with a connection is close it. And another relatively important thing you can do with a connection is to commit on it. We haven't said a lot about commit so far. I'll talk about it a little bit more when I talk about transactions. And basically the reason we haven't had to worry about it too much is we've mainly been dealing with databases via PSQL. And when you run a single SQL statement in PSQL, especially if it's an update type statement, it automatically does a commit as soon as that statement is executed. Inside these kind of systems where you may have multiple update operations occurring, they don't necessarily get fixed in the database until you commit all of the changes, and that's what what the commit method does. Okay, so you can say insert a tuple, insert another tuple, insert another tuple, and then you're supposed to say commit at the end. If you don't say commit, it's an interesting question what might happen. It's quite possible that, I haven't tried this, that Python does an automatic commit when you close the connection, for example. So if you close the connection, anything that's not yet committed might get committed. But to work all these things out, go and try them. Write little scripts like the ones I've been looking at, and you can see the fine details of the semantics. Now these aren't the only methods that you get with the connection object. There's a whole bunch of others, and there are some to do with isolations. Once again, transaction type notion that you can set things up so that if you make a connection, and then you make another connection and you don't want those two connections to interfere with each other, you can set them so that they're going to be isolated from each other, and there's a whole bunch of other stuff. So let's see, here we go. So if you go to the COMP3311 documentation, there's blah blah blah. Oh, I didn't mention rollback. So if you were doing lots of updates to the database and you said insert this tuple, insert this tuple, insert this tuple, and decided, oops, I didn't really want to do that, then you can say connection rollback, and all of those tuples will not end up in the database. Commit. So if you've got transactions going, if you've got updates happening to the database, that will commit, like I said, closing the connection. Then you can go down here and see there's a whole bunch of other stuff which probably isn't going to be that useful for us. We're basically connecting to the database and then asking queries on it. Right, so basically what cursors are, they're handles that allow you to do stuff with the database. The connection is something that gets you in. It's kind of like, I thought I had an example somewhere. It's kind of like when you go PSQL A2, you're setting up a session with the A2 database. That's pretty much what a connection is. Once you've got that connection, you can then start, you've opened PSQL, you can then start asking queries and so on. So that's kind of what cursors are. They're the things that will allow you to do what you do to the prompt in PSQL. So what can you do with them? You can execute queries, you can do updates, and you can even change the catalog data. So you can create new tables and so on. You can also do things like invoke stored procedures. Of course, you could do that anyway because we've typically been invoking stored procedures by doing select and then the function call. Right, so you create cursors from a database connection. You can create multiple cursors. Each cursor handles a single database statement at a time. And when I say a single database statement, you can actually chain a whole bunch of them together with semicolons in between. But one conceptual SQL statement at a time. Cursors aren't by default isolated from each other. So if you've got one cursor that's doing something to a table and you've got another cursor that's doing stuff to the same table, they can each see what the other's doing, and when we talk about transactions later, you'll see that that's not necessarily a good thing if they can both see the changes that the other's making. So be a little bit careful about opening multiple cursors. The other thing, having said don't open multiple cursors, that kind of solves the problem that we had earlier with this. Because these two queries, query 1 and query 2, are effectively like cursors. So if you can't actually, or if you shouldn't open two cursors at the same time, then you won't be doing things like this with the attendant inefficiencies. Alright, where are we up to? Here. Alright, so to create a cursor object, you simply take your database connection, run the cursor method, that gives you back a cursor. You assign it to a variable, and then you can start doing things with the database. All the examples call this thing cur. I'd almost be inclined to call it DB, because it's basically your handle on accessing the database. The connection that you set up initially, yes, that's all very nice. That just allows you into the database, but then when you want to start doing things to the database, I'd call it DB rather than cur. Alright, so probably the most important thing that you can do with a cursor is to execute an SQL statement. So it can take a single argument, which is just an SQL statement string, select star from some table. But a lot of the time we want to interpolate values into an SQL statement. So the first argument to execute isn't necessarily a complete SQL statement. It might be like a template, and we need to populate different parts of the template. And you can see examples down below. So in any case, so what current execute does, if there are two arguments, it'll take the values in the second argument and stick them into the appropriate places in the first argument, and we'll see how to specify appropriate places very soon. So once you've executed a statement on a cursor, you can then go and fetch the results from that using the cursor and using the fetch methods. There are a number of fetch methods for collecting results from a cursor. So here's some examples of how we might use a cursor. Just with a fixed SQL statement, nothing special in there. If we want to insert values into the SQL statement, we use this %s notation, and regardless of whether it's a number or a string or whatever, we always use %s. Kind of makes me wonder why they bothered with the s. They may as well just use % as a way of specifying that something has to be interpolated into there. There are other ways that you can do this outside execute. You can actually form the query elsewhere and then feed it into the execute statement. In any case, so what this is doing, it's Going to run the query, we might effectively want to end up with the same query as we've got up here. So it's a template. We say we're going to feed a value in as part of the where clause, and here we specify the value. Now, I reckon this is a little bit of a crappy Python thing, but the second argument, the values argument, has to either be a tuple or a Python tuple or a Python list. I'd argue that probably doing a list is the simplest thing, but if you've got a tuple that only has one element, you've got to be able to distinguish that from an expression, which is parenthesis around an expression. So if I wrote parenthesis 1 parenthesis, that's not a tuple containing the value 1. It's the expression whose value is 1. So there's a subtle difference there. So to make Python think you're dealing with a tuple, you've got to stick that trailing comma. If you don't want to do that, then you can just put it as a Python list, and it will recognise that, and it will take this value and stick it into the string in the appropriate place. It will also do things like put quotes around it if it's a text value that you're inserting, and also deals with things like if you've got an embedded single quote, it'll double that up when it appears in the final query. So here's another example, selecting students where the name is like some pattern. So here's the pattern, percent myth, percent, so Smith, Smithers, I don't know. I'm sure there are other names that have got MITH in the middle of them. So if I execute that, and notice here that what we're doing, we're assigning a string to a variable. Doesn't matter whether you have a string as the first argument or whether you have a variable which contains a value, which is a string. Same diff. So we're going to execute this query. We're going to interpolate the pattern into this location here. Execute knows that this thing, the value that we're interpolating, is a string. So when it ends up in here, it's going to be going to have quotes put around it. If you wanted to feed in just that part and have it wrapped up in percents, that's a little bit trickier, which is the reason why I did the pattern at this level. So it's sometimes a little bit obscure, not quite clear how your query is going to end up before it's sent off to the database, because you're interpolating values into it. So there's a way that you can look at what your SQL statement's going to end up looking like with a command called mogrify, which is basically the same pair of arguments as you give to execute, but it will do the transformation. It will insert the values into the tuple, return a string, which is the SQL query that execute would send to the database. So you can check whether you're going to get something sensible. So here we've got this query. We're going to interpolate the value 1 into it, and that's the result we get back. This B at the front means it's a byte string, which basically means it's a string of ASCII characters essentially, but it's a string. One thing that I hadn't done so far is interpolate more than one value, and you can do that. Simply have multiple percent S's, and then you have to give multiple values here. You can do more complicated things as well. You can give these things a name, and give these things a name, and it'll match things up, and you don't have to give the arguments, or you don't have to give the values here in the same order as they appear in the query, but who cares? Syntactic sugar. Alright, so here we've got two slots in our query. We want to fill those two slots. We're going to take this value, stick it in place of that, this value, stick it in place of that, and that's the result that we end up with. Here you can see that in this example where we interpolated a pattern into the string, it knows that this is a string being interpolated, and so it encloses it in quotes. That's nice. The other thing that's changed here, because it's enclosing it in single quotes, we now have to put double quotes around the overall string. Okay. In Python, single quotes, double quotes can both be used for strings. So, and you'd use double quotes if you want to stick single quotes in the middle. I guess you use single quotes if you want to put double quote in the string. And it even handles things like this. So we've got O'Reilly, which is a string with a single quote in it. When it ends up in the SQL statement, we want to make sure that it looks like that. So doubling up that quote because it's embedded in a single quoted string. Alright, that will do for the time being. And let's have a break and I'll continue with lots more examples of this afterwards.